Good evening. Now here we are talking about joint life annuity and also is a temporary annuity, right? So you have two lives and also it is a temporary annuity. To find this, what we will be doing is we'll be saying this exactly the same way as we do in our single life. We say a du x minus v raised to n npx and then a du x plus n, right? This was single life. For joint life, we'll do the same thing, but we'll have two lives. We'll have a du 6062 minus v raised to 5 5p 6062 and then we'll have a du 65 67. So we'll have to find both of these values from the table, and this v raised to 5 5p 60 62 will just be v raised to 5 5p 60 for male and 5p 62 for female, right? 4% rate of interest. Okay, we'll look up the PMA 92C20 PFA 92C20 values. Okay. So PMA and PFA 92C20. Into female probabilities 67 upon 65 67 upon 62. Mm-hmm. 67 and 62. 62 would be then joint life annuities we will calculate from this table, right? Here first of all D is going to be 2 because it is y minus x. D is 2. First age is 60. For 60 I am looking for plus 2. Plus 2 gives me 13.734. 13.734 minus answer into then 65 and then D2. 65 D2 gives me 11.586. So the temporary annuity becomes 4.5735. Is that clear? Any problem here? Okay, so we can find temporary annuity, okay, from this very similarly to what we had. So most of the joint life formulas are very similar to our single life formulas. Okay, even payable M times and stuff will be exactly same, the same relationship. Now let's do a few sums. So 22.5. A life insurance company issues 1,000 last survivor annuity to a pair of life age 60. Each pair comprises one male and one female, and the annuity pays 5,000 per annum continuously until the second of the two life dies. The single premium charged is 90,000. Calculate the expected present value of the profit to the life office and the standard deviation of this profit in respect of this group of policies. Okay, so basis is given are PMA 92C20, PFA 92C20 4%. Then they have also said using this mortality assumption, A bar 60/60 is given as this much at an interest rate of 8.16% per annum. Now what does that mean? When we say AX at the rate of 8.16%, that is basically 2AX at 4%. So it is 2AX at 4%. These two will be same. So what they are talking about is they have given us 2A bar 60/60 at the rate of 4%. This is given as 0.20021. This is what is given. This will be used for finding the standard deviation, right? So first of all, they are saying 1,000 last survivor annuity to pairs of lives aged 60. Okay, Dhruvika, yes?
Sir, how is 0.20021 as a 2A bar 60/60? Isn't it given just A bar 60/60?
You forgot how do we calculate 2A bar? If you did, you can see down here as well. Okay, so for 4% in AM92, if you see down here, what do they say? 2AX is equals to AX at 8.16%. Okay, it is the I dash that we calculate. Okay. So now let's calculate our value. So we have 1,000 policies, last survivor annuities to a pair life age 60. Each pair comprises one male, one female and pays the annuity 5,000 per annum continuously until the second life. So if I say expected present value of benefit, our expected present value of benefit is going to be 5,000 A bar, and A bar will have what is it? Ages, both ages are 60, 60 and then bar. Right. This is what our expected present value of benefit is going to be. So how do we calculate this? We'll say A bar 60 will be equal to A bar 60 for male plus A bar 60 for female minus A bar 60 joint life. Bars, what happens is we will subtract by half in each one of these. So we'll have ADU 60 male plus ADU 60 female minus ADU 60 and minus half from here, and then because here I have minus here, I will get plus half. So basically I am left with only minus half. That is only will be left. Minus half and plus half from here. Okay. So first of all, ADU 60 for male is 15.632, for female 16.652 minus joint life 60. When we say 60, our D becomes 0. So for D0 and X age is 60, we are getting 14.09. 14.09 minus half. And we'll have 17.694 into 5,000. So expected present value of benefit becomes 88470. Right. We want expected present value of profit. Expected present value of profit would be 90,000 was the single premium charged minus 88470. We have 1530 per policy. In this much we have per policy. We also said that 10,000 policies were sold. Right? 10,000? No, 1,000 policies were sold. So just multiply it to 1,000. I'll be back in just 1 minute. Okay. Okay. So expected profit. Expected total profit, let's say. Total profit this is what our expected total profit is. Right. What about our variance? For variance, we know for annuity, if I want to calculate the variance of our annuity, that is our A due, or let's say A bar kx plus 1 for this, actually tx, A bar we will have tx, A bar tx. The variance of this was 1 by delta square 2 a bar x minus a bar x the whole square, right? This is what our variance used to be, right? So same thing will happen with joint life in both cases. Here, if I want to calculate variance of a bar txy bar, okay, txy bar, so that is going to be 1 by delta square 2 a bar xy bar minus a bar xy bar whole square. So this is given to us. They have given this value, right? So this 2 a bar 60 bar for 4% is given to us. We'll calculate this. So a bar 60 bar. Now there are two ways of calculating this. One could be, you can say this is approximately 1 plus I raised to half times a 60 bar, and then calculate this a 60 bar. Okay, a 60 bar we'll say is going to be 1 minus d times a due 60 bar, right? So we can definitely use this, or the second would be we can directly relate it to annuity, continuous annuity. So continuous annuity, I will get 1 minus delta times a bar 60 bar. Okay. Both of these will give you almost the same answer. There will be a slight difference, but both are acceptable. Okay, both are acceptable. Okay, now here we have already calculated our a bar 60 bar. That is our 17.694. So let's use this directly. I'll have 1 minus delta would be log 1.04 into 17.694. Okay, so we can calculate the variance of a bar, that means the annuity that we are talking about, txy bar. Okay, that would be 1 by delta square 1 by log 1.04 square into the given value was 20021 minus 0.306028 square. Right, so we get 69.27084. Okay. Now variance, this was just variance of the annuity factor. This was just variance of this part. Okay, if you want to calculate variance of our profit, see variance of profit, because it is variance of we'll say variance of profit will be equal to, first of all, 90,000. It's a variance of 90,000 minus 5,000 A bar TXY bar. Right. This is what we will have. So we have calculated variance of this, and because this is a constant, there is no difference in the variance. And whenever we have variance, constant comes out. Whenever constant is multiplied, it comes out, but it is the square. So I will have 5,000 square into this, that is our 69.27084. Okay. And this gives us how much variance? 69 into 1, this is our value 17317710003. Okay. Sir, variance of our profit. Now this is for one policy. This is for one policy. If we want to calculate for 1,000 policies, we will just multiply it by 1,000. Remember this, variance will be multiplied by 1,000. Standard deviation will not be multiplied by 1,000. Okay. So variance for one policy. So you can say variance for 1,000 policies will be 1731771003000. Okay, this is what our variance for 1,000 policies would be. And then standard deviation for 1,000 policies will be under root of this variance, under root of this. Just multiply this by 1,000 and then take root, and this becomes our standard deviation, 1315967.7. Okay. So why variance is multiplied by 1,000? Why not standard deviation multiplied by 1,000? You learn that in CS1. If you have studied CS1, then you know, right? Independent policies, so variance will be added together. Right? If not, don't worry. When you will study CS1, you will understand. Let's solve another question. Saying William, age 75, and Laura, age 80, are the guardians of a child. They take out a life assurance policy that provides a payment of 25,000 immediately when the second of them dies. Level and premium are payable in advance whilst the policy in force. Calculate the annual gross premium using the basis, and then we want to calculate the reserves as well. Okay, in the second part. So first let's calculate the premium. So here we have an assurance policy. Okay, so we'll say our expected present value of premium first. So they are saying premium is payable in advance whilst the policy is in force. So till when the policy is in force? If you see here, the payment is given immediately when the second of them dies. Okay. So second of them dies. So that means we are talking about last survivor. So the premium P would be given till the second death. So we'll have 75, 80 bar. We are talking about last survivor. So let's look up this 75, 80, or we'll do that later. Okay, then expected present value of benefit. Expected present value of benefit. We'll have 25,000 immediately. So A bar 75, 80 immediately. Okay. Then they are saying we have some expenses as well. So let's look up the expenses. We have initial 250 and we have renewal. Renewal is 5% of each premium, so 0.05 P A due 75, 80 bar minus 1. These are expenses. So let's find A due 75, 80 bar. A due 75, 80 bar, we'll have A due 75 for male plus A due 80 for female minus A due 75, 80, right? Let's look up these values. A due 75 for male is 9.456. A due 80 for female 8.9 minus joint. For joint first D is going to be plus 5, right? D is going to be plus 5 and X is 75. So 75 going for plus 5, it seems 6.822, 6.822. 6.822. 11.623. Then assurance, okay, we have this. I can say it would be A bar 75, 80 can be written as 1 minus delta times, say A due 75, 80 bar minus half, because I want A bar there. So just subtract half. This will be easier. I'll subtract half here, so I'll get 11.123. This much. 0.563748 multiplied by 25,000. Okay. then expenses 10.623, right? 10.623. So we'll have 250 plus 0.53115p. So P will be 14093.7 plus 250 by 11.623 minus 0.53115. One two nine 3.175. This becomes our premium. For the second part, they're asking us calculate the gross premium reserves just before the 6th premium is paid. That means at the end of the 5th year. Using the basis given below, assuming both William and Laura are still alive at that time. Now see, if they did not say that, if they would not have said that both William and Laura are still alive, then we would have to take into account what would happen if Laura dies and William is alive. What happens if William dies and Laura is alive, and what happens if both of them are alive. I will show you how to calculate that as well right now. With this same example, we will take all three cases into account and see what would be our total gross premium prospective reserve. Okay, so first let's just calculate assuming both are alive. Okay, both alive at time 5. Right. If both are alive at time 5, then we'll say 5v must be equal to 5v at that time 5 premiums have already been paid, and we are so we'll talk about benefit. Okay, 5 years have gone, so we'll have 25,000. A bar 80, 85 bar. Okay, then out of this expenses 250 was initial gone, and then 5% of the premium, so we'll just directly subtract it from the premium, minus I'll say 0.95 p. 95% of the premium is only accessible, so A due 80, 85 bar. Right, this is what our this is going to be. Let's calculate. $80 male, $7.506 plus 85 female 7.220 minus joint life. Joint life we are looking for plus 5 for male being age 80. Male being age 80. And so this is the third value, and we want for plus 5. Plus 5, 5.161. So we have 9.565. Okay, 9.565. And then A bar 80, 85 bar will be 1 minus delta times ADU 80, 85 bar minus half. It's 0.644464. .95 into premium. So reserves turns out to be 4360.85. This becomes a reserve for both alive. So this is what they actually asked. But as I said, if you want to calculate reserve when they did not specify what happens, so we have to figure out what would happen if one dies and the second lives. So first of all, if male dies and female, see, benefit is given only on the second death. There's no benefit on first death. There's no change in benefit after first death. Premium is still paid till the second death, right? So there is no change. The only change would be that rather than talking about last survivor out of 2 lives, if first has already died, then we don't consider that life, right? So I will say if male dies and female alive at time 5. As I said, this is what the answer is for this question I'm talking about now. What if they did not specify that both are alive? Then how would we find the reserves? So we'll also calculate male dies, female alive. So for that I will say it is 5VF only for female. Okay, I'll say 5V reserve only for female. So I'm saying at time 5 female would be age 85. So right now I'll say it is 25,000. A bar 85. Okay, payment given immediately on death of female. So you can write F here. Minus 0.95 premium is supposed to be paid till the death of again female. Right. So I'll just directly write this equation. I'll have 25,000 into 1 minus log of 1.04 into whatever was the ADU 85 female. Let's look up ADU 85 female minus half, right? So we have 7.22 minus 0.5 bracket close, another bracket close, and then minus 0.95 into what was the premium, which is the premium, multiplied by 7.22. So this becomes the reserve if male dies and female is alive. 9541.03233. This is the reserve we will keep if male dies and female is alive. Similarly, what if male alive and female dies at time 5? So we are not saying that they are dying exactly at time 5. We are saying that they are dead by this time. Okay. So we are saying any time before this, the death would have occurred. So we'll say reserve for male at time 5. It would be 25,000. A bar 80 is the life age, right, for male. 0.95. Again, premium would be paid 80 for male. Again, in this, we'll just change the male 87.506. We'll edit this 7.506. This becomes our reserves. $8909.25, and then total reserves or total 5V, we would have said how likely is this to happen? How likely is both being alive? How likely is one dying and the second being alive? So we are saying probability that both will be alive would be 5P. 5P, what were the ages? I think 75 and 80, right? This is the likelihood of both being alive. So if that happens, we will have to keep, I will write here B, both being alive, 5VB. So I'll say 5VB, both being alive, we have to keep this much reserves. Or one dies and the other is alive. So let's say within 5 years, male dies. So within 5 years, male dies and female is still alive. 5P 80. Okay. Within 5 years, male dies and female is still alive. Then we will be keeping this much reserve. So we'll say 5VF. This is the reserve that we are going to keep. Or the third thing that can happen is male is alive and female died, right? 5P 75 male and 5Q 80 female. And then if that happens, this is the reserve that we will keep, 5V. This becomes the total reserve we will keep at time 5 if no other condition is given. We don't know whether both are alive, one died, one alive. If that happens, this is how we will be making our equation for reserves. We will take into consideration all three cases. Both alive, one dies, the other one lives. Of course, If both die, the policy ends. That is why we are not considering that, right? If both dies, policy ends. Okay. Very rarely they ask us this, but they may. That is why I want you to know how to solve if no condition is given. Otherwise, they always say either both are alive or male has already died and female lives. How much reserve should we keep? These kind of questions they make. Okay. Many times we have conditional annuity, in that if male is alive and female has already died, this much amount would be given and that much amount would be given. So different amounts are given at different rates. I think this is the question. Let's see. 22.8. 22.8. Here we have a man age 60 exact and a woman age 65 exact wish to purchase an annuity that provides 25,000 per annum payable while they are both alive, 20,000 payable for the remainder of the woman's life if man dies first, and 15,000 payable for the remainder of man's life if woman dies first. Okay. So in the next chapter, we will learn how to calculate what happens, or how to calculate the annuities if one dies and the second is alive. Okay. But this can be solved using the concepts that we have already studied here. We can use those concepts to figure this out as well. How would we do it? Okay. So first of all, just make a timeline. Let's say at this point, X and Y both are alive. Okay, at this point, X and Y both are alive. And at a certain point, let's say X plus N or Y plus N. Okay, after N years, one of them dies. We don't know which person dies. Okay, we don't know which person dies at this point, but one of them dies here. And the second one dies somewhere here. X plus M, Y plus M. Okay. So first person dies here and the second person dies here. Okay. So we call this part as joint life, right? Both of them were living at this time. That is why it is called as joint life. This part is called as last survivor. Okay. So at this point, both lives were living, from taking the policy to this death of the first life, and till the death of the second life, we'll call it as last survivor. Okay. Now, whenever we are trying to calculate how much payment should be given at what point, what we can do is we can use these terms to figure out how much payment was given to what person. So see, if I say 20,000 given to female, okay, let's say from the beginning, see what they have said is 20,000 was payable for the remainder of woman's life if man dies. Now let's assume that 20,000 given to female, irrespective of male lives or dies. Okay. So we are saying 20,000 is given to female irrespective of male lives or dies. Okay, that is not what they have said here. They've said starting from the man's death, then the woman gets 20,000. That is what is given here. But let's assume 20,000 is given to female irrespective of male lives or dies. Similarly, I will say 15,000 given to male irrespective of female lives or dies. Now here I have made a condition where they are not related to the other's death. We are not related to the other's death. We are saying 20,000 given to female irrespective of male's life and 15,000 given to male irrespective of the female's life. So what are we getting here? So let's assume that we are at this time x and y at the beginning. Let's assume that if x dies at this point, let's say if x dies at this point, then we are assuming x dies first and female dies later. I'll say y plus m. Okay, so x dies here, y dies here. So we said that 20,000 was given to female and 15,000 was given to male. Okay, I'll just say 20,000 plus 15,000 was given to both of them, right? Both lives, 20,000 plus 15,000. And as male dies, only payment to the female is left. So I'll say 20,000 is left. Okay. And if female dies first, I'll say y plus n, female dies. If female dies first, again 20,000 plus 15,000 was given for joint life, right? When both were alive, this much was given, and only 15,000 is given when female dies, because 20,000 was given to the female. So according to this, according to the conditions that are given in the question says that 20,000 payable to the remainder of woman's life if male dies first. So if male dies first, 20,000 given to woman. That is perfect here. And they said 15,000 payable for the remainder of man's life if woman dies first. 15,000 given to the remainder of man's life if female dies first. That seems perfect again. The only problem is this joint life. In this joint life, together they are getting 45,000. Together they are getting 35,000, not 45. Together they are getting 35,000. Now what if I say I am giving 10,000 less till both are alive? Till both are alive, then 10,000 is given less. That when both are alive, that is called as a joint life. So I will subtract 10,000 in joint life. Similarly, if I subtract 10,000 here in joint life, then what is happening? In total 25,000 given. In total 25,000 given when both are alive. So this is how we will make this equation. We will say 20,000 given to female. So ADU. What were the ages? Let me just. Male 60, woman 65. So 65 female. Okay. Now one thing I prefer is, rather than writing it like this, that I would, sorry, this would be first of all 65. I would suggest you all to follow as well rather than writing it like this, what I do is at the beginning I say x is equals to 60 and y is equals to 65. That way I just have to write x and y, and I know y is always used for female and x is always used for male, so I don't even have to specify which one is male and which one is female. So I say our expected present value will be 20,000 given to female plus 15,000 given to male, but in joint life 10,000 is subtracted. In joint life 10,000 is subtracted. Okay, now I think this was all arrears. Yes, all the annuity payments are made annually in arrears, so these should be arrears, arrears, arrears. Now is this understood? 20,000 ADY minus 1 plus 15,000 ADUX minus 1. We'll have 10,000 ADUXY minus 1. Calculate this and let me know how much it is. I'll be back in 2 minutes. Okay, so do you calculate these values? We have 20,000 for female, age 65, we will have 14.871. For male, age 60, we'll have 15.632, and joint life, so finally we'll get 375,890. Okay, so this was our expected present value. Now they did also ask us to write down the expression for the present value of the random variable of this benefit in the first part. Okay, so first part they asked us to write down the present value. Okay, present value, I always prefer writing from this. I have already made the expected present value. I can write present value. I'll say 20,000. Present value of this would be A T Y arrears plus 15,000 A T X minus 10,000 A, this is XY joint life, so T XY, sorry, not T, it will all be K, my mistake here. T is for continuous, right? So K Y, this would be K X, and this would be K X Y. Arrears. Okay, if you understand this concept, then joint life is very easy for us. Okay. The next chapter, that is our chapter 23, is continuation of this joint life. Okay, so we have chapter 23 is name, I think, contingency. Contingent and reversionary benefit. Okay, so we have contingent and reversionary benefit. So we are talking about benefit that are contingent. The word contingent just means that there is some conditions applied. So if some conditions are applied, then it becomes contingent. So if something happens, then the benefit would be given. So that becomes a contingent benefit. Reversionary benefit, that means we are keeping on revising it. Okay. So like annuity, usually reversionary is used for the annuity term. So if I say reversionary annuity, that means I'm giving you annuity every single year, but if something happens, I will change that annuity. Maybe increase it, maybe decrease it, whatever happens. Okay. So sort of in this case, that happened. We said that 25,000 would be given to joint life. Then if male dies, then it becomes 20,000 for the life of the female, and if female dies, then it becomes 50,000 for the life of the male. So this question we had reversionary annuity. That means we were keeping on revising the annuity depending on some condition. Okay. So that is our contingent and reversionary annuity. Okay, now we'll study this next time. We'll not put a lot of stress here. I want that next next Saturday, you should revise everything that we have studied in chapter 22, because it will be very important for us to study chapter 23. We need to be very well versed in chapter 22. Okay, because we are continuing our joint life part here. And of course, it will be a little bit more complicated. So I don't want you to get confused, because your base of joint life is not very clear, right? So I want you to solve as much as you can from the book of this joint life. Now I'll be releasing one more, doubt lecture tomorrow morning. Okay, so last time we had a lot of doubts, and I made one doubt lecture, but I could not cover all of them. I'll be making one more, and tomorrow morning I will be posting that. And of course, on Wednesday, we will have a regular doubt lecture. Right. So today we'll just end our class here, and we'll meet for our doubt lecture Wednesday. Okay. Yes, Dhruvika.
Sir, please post the test solution of chapter 12.
Solution of chapter 12. Have I not posted that?
Sir, last time I checked, it wasn't there.
Let me see. It is there, see, solution chapter 12. Or test. Are you talking about test?
Yes, sir.
Yes, I have not posted the solution of the test. Yes, I'll do that right now. Okay. Okay. And this Saturday, Sunday, I will, this Wednesday, I will be giving you test of chapter 13 and chapter 14 both. Both will be given this Wednesday. Okay, so if you have any doubts left in chapter 13, chapter 14, do ask me this Wednesday. Okay, so let's end our class here, and we will meet on Wednesday. Bye.